Hello everyone, welcome back. Today in this video we'll discuss about Poisson distribution. So first we will see what is Poisson distribution, then we will also look at some of its assumptions, and then we will also look at equation of PMF of Poisson distribution. Then we will look at some of the practical use cases of Poisson distribution, and at last in the notebook section we will try to generate data which follows Poisson distribution, and also we'll try to plot some PMF and CDF of the data which we have generated. So first let's start off with the definition of Poisson distribution. Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time if these events occur with a known constant mean rate and independently of the time since the last event. In simple terms, it tells you the number of events occur in a particular period of time. Now let's look at some of the assumptions associated with Poisson distribution. The first assumption is the rate at which the events occur is constant. And the next assumption is all the events are independent to each other. In practical, it is hard to find any use case which are following these two assumptions, but still if we can probably come up with some use case where these two assumptions are not actually that big of a deal, then we can always imply Poisson distribution and find some of the various properties from the data. So these are the assumptions. Now let's look at the equation of PMF. So this is the equation of PMF. P of x equals to k is equal to e to the power minus of lambda to the power k whole divided by k factorial. So here we have only one parameter, which is lambda, and also the mean of Poisson distribution is lambda, and also the variance is lambda. Now some of the practical use cases for Poisson distribution can be text messages per hour, and machine malfunctions per year, website visitors per month, or the number of cars passing a toll, or number of customers coming into the shop. Now let me take you to the IPython notebook and or collab notebook and show you the distribution and some of the plots there. So in this notebook again you can see the equation here which we will use to calculate the PMF for the data that we will generate. So here to generate the data I am using lambda equals to 5, so mean will be 5, and I'm randomly generating 1000 data points, and I'm also calculating mean and variance just to show you they are close to each other. And you might say it's not equal to 5, so yes, they won't be exactly equal to 5, but they will be very close to 5. Now I'm plotting here the count plot. So as you can see here, we have data from 0 to 12, and most number of data points here that we have is 4 and 5, so that's why the mean is coming very close to 5. And also you should not confuse this count plot with probability distribution plot. So here we have 1000 data points that we have generated, so if we divide these counts by 1000, that will be our probability distribution. Now here in this cell I will try to calculate PMF and CDF, but for that first we need to extract all the values that we have in our data. So as we know that it is a discrete distribution, so we will have all the integer values. So we have generated 1000 data points with mean 5, so we will have some data points. So I'm using and also one thing you need to know about Poisson distribution is that you cannot have values less than 0, because if you practically think about it, you cannot have a negative number of events happening in a particular time. So you cannot have negative visits on a website, you cannot have negative customers coming into your shop, right? So it starts from 0 and can go all the way up to infinity. So here I have taken mean as 5, and we have all the unique values here. So we will be using xval to calculate PMF and CDF, and also we will provide the lambda. So we saw this equation here as well and also in the slides. So you can see we have np dot e to the power minus lambda, and then we are multiplying it with np dot power. So it's basically lambda to the power of xval, and here xval is nothing but k, and we are dividing it by factorial of k or x values. So that's what is it. And for CDF we simply need to integrate our PMF. So here I'm doing np dot sum of PMF, so that will give us CDF. Now if I try to plot them, you can see it is very much similar to our count plot, but when you closely notice the y-axis, now it has been divided by 1000, so this is 0.175. so that's what our PMF is. And now if we try to plot CDF, it looks something like this. So that's how you can find PMF and CDF. But here I have used the formula, and you don't need to actually write the formula. You can simply use SciPy package. So that's what your assignment will be or task will be. So what you need to do is generate data which follows Poisson distribution with lambda equals to 10. So here I have generated data with lambda equals to 5. So you need to do it with 10. And then you need to calculate PMF and CDF using SciPy package. So that's what you will do. After that you will have to plot the PMF and CDF of the data, and then also you need to find mean and variance of the generated data just to see whether they are equal or not. So that's what your task will be, and this is it what I wanted to discuss in this video. I hope you were able to understand Poisson distribution in a better way. So hope to see you in the next one. Happy learning.